Sonia, we can do math and work with strings, but how do we make the computer decide things?
That's what if statements do. They let Python make choices. You give it a condition, and if that condition is true, it runs the indented code block. A condition is anything that evaluates to true or false. Like 5 greater than 3 is true, or name equals admin is true. These are boolean expressions. To write an if statement, type if, then the condition, then a colon. On the next line, indent your code with 4 spaces. Only indented code belongs to the if block.
So the if checks the condition, sees it's true, and runs the indented code. What happens if it's false?
With if alone, the indented code is skipped entirely. But you can add else to run a different block when the condition is false. Else has no condition of its own. Else must come right after the if block at the same indentation level. Only one of the 2 blocks runs, never both.
What about more than 2 options? Like grading scores A, B, C, D, or F?
Use elif, short for else if. You can have as many elifs as you want between if and else. Python checks each condition in order from top to bottom. The first condition that's true runs its block, and the rest are skipped. If none are true, the else block runs as the default.
So if checks first, then each elif in order, and else catches everything else. That's very organized.
Combine conditions with or, and not. And needs both sides true. Or needs at least one side true. Not flips true to false and vice versa. You can nest if statements too, put an if inside another if. The inner if only runs if the outer condition is also true.
So nesting means both conditions must be true at their own levels. Can I go as deep as I want?
In theory, yes, but deep nesting gets confusing fast. Usually 2 or 3 levels is plenty. Let's go to the lab and write real decision-making code. Our first if. Number is 5, which is greater than 0. The condition is true, so Python prints positive. Simple and clean.
If we change none to negative, the condition would be false and nothing would print. The if block is completely skipped.
If else gives 2 paths. 7 modulo 2 is 1, not 0, so the if is false. Python skips it and runs else, printing odd.
The else has no condition, it only runs when if fails. So one branch always executes, either even or odd.
Elif chain for grades. Score is 85. Python checks 90, false. Then 80, true. It prints B and skips the remaining elifs and else.
Python checks top to bottom. The first true condition wins. If score of 55, all checks fail and else prints F.
And requires both sides true. Age 25 is over 18 and under 65, both true. It prints adult. If age were 15, the and would fail and go to else.
If the and passes, we check elif for senior. Age 65 or more goes to senior. Everything else falls to else as minor.
Or needs only one side true. Day is Saturday, which matches the first condition, so the entire or is true. It prints weekend and skips else.
If the first condition is already true, Python doesn't even check the second. That's short-circuit evaluation. It's efficient.
Nested if. The outer if checks if user is administration. Only if that's true does the inner if check the password. Both must be right to print welcome.
If user is not admin, the outer else runs straight away. The password check never happens. Great for multi-step validation.
The temperature ladder checks hottest to coldest. 28 is not above 35, but it is above 25, so warm. Each Elif runs only if all previous conditions were false.
Order matters. If warm came before hot, hot temperatures would incorrectly match warm. Always put the most specific condition first.